let's look at another way of solving this problem, and it will help to make a little sense out of the decimals for us and how we get these answers. So if I look at this same problem, 1.85 times 25, I can convert the decimal to a fraction and do the multiplication of fractions and see that I come up with the same answer I did when I multiplied using the vertical stacking method. So if I look at 1.85 as a fraction, I have 185 100ths. 185 over 100 is the equivalent fraction to 1.85. And then multiply that by 25, and any whole number can be easily converted into a fraction by simply putting that whole number over 1. And so I now have a problem of 185 times 25 in my numerator and 100 in my denominator. So 185 times 25 equals 4,625. So that's what I have now in my numerator. And then that's all over 100 times 1, which is 100 in my denominator. Well, 4,625 divided by 100 is equal to 46.25. which is the same answer that we got when we did the multiplication the other way, 46.25. And one way you can look at this in the real world is if, for example, you had a candy bar that cost $1.85 and you bought 25 of them, maybe one for each person in your class, you would end up spending $46.25 on your candy bars. When you are multiplying with decimals, you can remove digits that aren't important to the answer. And those are usually removing zeros. When we're talking about removing digits, we're not just removing numbers out of the number, we're taking zeros out to make a simpler problem with our decimals. So let's look at an example of this. If I have 0.280 times 8, and I'm going to set this up by removing my decimals, counting how many I have to the right first, and then removing my decimals and setting my problem up, I might look at it and go, oh, okay, I need to do 0.280 times 8 and work on that, 4 digits multiplied by my 8. However, if I simplify this 0.280 first, I have a much simpler problem to work with. So instead of this, what I'm going to do is I'm going to remove these unnecessary zeros that aren't going to make a difference in my answer. So I could rewrite 0.280 as simply 0.28 times 8. And so what happens in this case is we are used to writing a 0 out here in front because when we're reporting answers or we're giving final solutions, we always want to have a digit in the ones place position, which would be here. And so we do add that 0 to this position. But for the purposes of doing work and doing multiplication, setting up a problem, we don't need to have that 0 here. 0.28 is the same as 0.28. And then this 0 here at the end can be removed because it's not holding any position in our decimal points. So 0.280 can be rewritten as 0.28 times 8. Now I have a much simpler problem to work with. I can continue by setting this up and do my 0.28 and my 8 here, multiply. I count my 2 digits to the right of the decimal point. I put that over here so that I know I've got 2 digits to the right of the decimal and I need to have that same number in my answer. Now that I've set it all up and I've counted my decimal places, I can simply remove the decimal point from my problem and now I have a very simple problem, 28 times 8. And I just need to do my 8 times 8 equals 64. Put my 4 here, carry or regroup the 6. And then 8 times 2 is 16. Add 6 is 22. And so I simply put my 22 here. And I have an answer of 28 times 8 equals 224. But I don't want to forget that I'm working with decimals. And my answer has to have 2 digits to the right of the decimal point. So I can come over here and put my decimal here and count 2 to the left and put my decimal right there, making sure that indeed my answer has 2 digits to the right of the decimal point. And so you can see that it's very simple to work out a problem like this with my decimals when I remove the unnecessary zeros.